That is, it increases the boiling point. Impurity increases the boiling point. Let's quickly talk about evaporation. Evaporation occurs when molecules on surface of the liquid are able to gain enough kinetic energy to leave behind molecules below that have the low kinetic energy. Evaporation occurs on the surface of the liquid. That's one point you have to take note. Evaporation occurs on the surface of the liquid. Evaporation occurs silently. It occurs silently. Evaporation leads to cooling. Evaporation leads to cooling. Let me give an example. By the time you sweat, by the time the sweat begins to dry from your body, you begin to feel it that there is now a breeze, maybe a air blow, and then you begin to feel the coolness. Okay? Evaporation, by the time the sweat begins to evaporate, it leads to cooling. Let me also talk methylated spirits. You have methylated spirit you have poured on your body. By the time it starts evaporating, you feel the cooling. So evaporation leads to cooling. The evaporation is affected by the rate of removal of vapor. Evaporation occurs at all temperature. Evaporation also occurs at all temperature. And those are the things we are going to take notes about change of states. So from here now, we are going to consider some questions. And we are going to make use of what we have talked about so far. Question number 1. An electric heater is used to melt a block of ice of mass 1.5 kilogram. If the heater is powered by 12-volt battery and a coil of 20 ampere flows through the coil at 0 degrees Celsius, calculate the time at which the whole process takes place. We are given the value for the specific latent heat of fusion of ice to be 336 times 10 to the power 3 joule per kilogram per Kelvin. In this case, we are going to make use of the substance that supply heat. Okay? And it's going to supply an amount of heat that is high VT is equal to ml. High VT is equal to ml. What is our high? That is the 20 ampere of current as flow. This is 20. We are given the amount of voltage, 12. We are looking for time, which is equal to, what is the mass of block? 1.5. Then we are given the latent heat of fusion of ice, which is 336 times 10 raised to power 3. Our T will be equal to 1.5 times 336 times 10 raised to power 3 divided by 20 times 12. So from there we can have what we would like to do here now. If we try to multiply all this together, 10 raised to power 3 is automatically 1000. Then let's multiply 10 raised to power 3, which is 1000, by 336. At the same time, by 1.5, we are going to have 504, then 000. Then what about 20 times 12? 20 times 12 will give us 240. So let's try and divide it all two. At the same time, we are going to have 544 divided by 240. We have 2,100 seconds, and that is the time that the whole process will take place. By the time the electric heater is trying to supply heat to the block, to melt the block, we have 2,100 seconds. And that's the solution to question number 1. Question number 2 says the latent heat of fusion of ice is 80 calories per gram. How much heat is required to change 10 grams of ice at 0 degrees Celsius into water? Quantity of heat is equal to ml, okay, at 0 degrees Celsius. We are looking for latent heat of fusion, which is L. So make L will be equal to Q over L. We are given the quantity of heat to be 80 cal per gram. We are given the mass of the water to be 10 grams. This is 8 calories. Okay? On this we cancel this. So the answer is 8 calories, which is the latent heat of fusion. That is 8 calories. Option C. Question number 3. The following are some units. We have the first one, Newton seconds. Another unit, Newton meter. Another unit, Newton per meter squared. For 4, we have Joule per Kelvin. For 5, we have Joule per kilogram. The question says, what is the unit of latent heat? What is the unit of latent heat? Out of all this we have, this is Newton, which is force. Seconds, that's time. And this is impulse. Impulse is force times time. Impulse, that's that. Let's look at this. Newton meter, force times distance, this is work. Newton, this is force times, this is per meter squared, this is pressure. So this is force over what? Over area. This one, not relevant. This is the right answer for latent heat. Why? The quantity of heat is ml, so that L is Q over M, and Q is the quantity of heat, which is joule. Our M is mass, which is kilogram. When you take it together, joule per kilogram. Joule per kilogram. And that is the right answer for latent heat. It can now be latent heat of fusion or latent heat of vaporization. But this is the right answer for latent heat. Question number 4. Question number 4 says, the latent heat of fusion of a substance is the heat required to A. Raise the temperature of unit mass of the substance by 1 degree Celsius. B. Maintain unit mass of the substance at constant temperature. C. Change unit mass of substance from solid to liquid at constant temperature. D. change unit mass of liquids to vapor at constant temperature. If you raise the temperature of unit mass by 100 degrees Celsius, the right answer is C, which is change unit mass of substance from solid to liquid at constant temperature. And that's the right option, option C. Because I have told you that the latent state of fusion is equal to solid to liquid. Solid to liquid at constant temperature. And that's that. Question number 5. How much heat is required to convert 20 grams of ice at 0 degrees Celsius to water at the same temperature? And we are given the specific latent heat of ice to be 336 joule per gram. Joule per gram. How much heat? The quantity of heat is ml, and we are given the mass, which is 20, and we are given the value of L, which is specific latent heat of ice, to be 336. And when we multiply that together, we are going to have 6720 joule. And that's the answer to question number 5. Let's look at question number 6. Calculate the heat required to convert 20 grams of ice at 0 degrees Celsius to water at 60 degrees Celsius. As I've explained the other time with the diagram, we have ice, we have water, then change in temperature. From ice to water, it is still at 0 degrees Celsius, 0 degrees Celsius. That is ml. Then from 0 degrees Celsius,